So I'm going to talk about energy in materials, and I have about 2 minutes, so I'm going to make it quick. Only 2 things you need to know. Or 4 things, actually. Getting your hopes up there. If you have a graph of force against change in length, it looks something like this. The area of the graph is energy. Okay, 1. If you have a graph of stress versus strain, the area under the graph is energy per unit volume, 2. Okay? So, depending on how far you want to go. Energy per unit volume. 3. If you want to get from energy per unit volume to energy, you multiply by volume. Makes sense. Energy per unit volume multiplied by the amount of volume gives you how much energy in total. And if you want to get from energy to energy per unit volume, you divide by volume. And volume equals area times length. So we talked about before. 1, 2, 3, 4. That's everything. So now, come in. Just give me 1 minute though. So now this eraser over here, if I press on this with a certain amount of force, it changes length. So that's a force by changing the length graph. Okay, and that'll tell me how much energy is in this eraser. Easy. But if I wanted to know the properties of rubber, okay, I have to forget how I have to ignore the volume of this, because if I had a big eraser, it could store more energy. So I have to divide by volume. So that's what we do here. Stress is force divided by area. Strain is change in length divided by length. So that gives us information about rubber. This is about rubber itself, and this is about an eraser. And that's why, if I divide by the volume of this rubber, then I can tell you how much energy per unit volume there is, and that's a property of all rubber. Whereas if I get the property of all rubber and multiply it by the volume of this eraser, this tells me how much energy is actually in this eraser. Everything you need to know about energy materials. Great. So good luck with that.